I joined Cloudera and then managed to get this project off the ground at Cloudera. So this was basically the genesis of Apache Impala.
Marcel, thank you for joining us at 20-Minute Leaders.
Michael, thanks for having me.
Of course, it's very gracious of you to give us your time. I know how busy you are. And, I would just love to go ahead and get right into, tell us a little bit about your background, where you came from, and I'd love to go all the way up to the founding of Apache Impala.
Sure, happy to. How far back do you want me to go? How I ended up in the U.S.?
Let's start all the way there. Sorry,
Okay.
that's Benny, my new dog. He's just giving us a little
Benny
trouble.
saying hi. Hello, Benny.
Hi, Benny. Say hi. Okay, I'm gonna go on mute while you talk, just that if he barks.
Of course, no worries. So I ended up coming over here because I was a student in computer science in Hamburg, University of Hamburg, which is where I'm from, in Germany, and I was very interested in databases and in the work that Michael Stonebreaker did. So I found a way to come over to Berkeley as an exchange student, and I ended up basically showing up on Stonebreaker's doorstep in his office and asking if I can do volunteer work, which I then ended up doing. So I ended up doing some bug fixing on Postgres and became part of ended up being a staff programmer in his research group. And that was back in the mid-90s. And then I left in order to finish my degree in Germany and then reapplied as a regular grad student. So this is how I ended up as a grad student at Berkeley.
Okay.
And I'm very grateful, that I actually had that opportunity. And Mike Stonebreaker had been helping me a great deal. So my professor then was Joe Hellerstein. Stonebreaker had left and gone to MIT. Mm-hmm. And so I was his first grad student. I graduated in 2000. That's when I got my PhD. And then started working at a bunch of database-related startups. But in the early 2000s, it was the dot-com bust years. And I had a total of 4 jobs in 3 years. The companies went out of business or, things like that happened. So it was kind of a dicey time. And
so it's pretty much the same as today's software engineer when they bounce from companies, except back then it wasn't your decision. It was because the companies went bust.
It was basically, let me find a new job while I'm on my H-1B. So it was a little dicey, but eventually I joined Google. And so I ended up at Google in 2003 and was working there, took a little break from databases. Before then, I had only worked on database internals and execution, and started working on the ad serving system and seeing database technology more from a user's perspective. So, and I then started to appreciate different aspects of it. Previously, I had only worked on database technology from the producer perspective, and you work on shrink package software, but you never see it deployed and how it's being used.
Right. So really, so maybe outline quickly the difference between the two types of consumers, from the producer side and from the consumer side of databases.
How is that different? Well, yeah. As an engineer, I never had any touch points with the users of the software that I wrote. Basically, that was like a far away, right? I guess there were some salespeople and there are sales engineers and all that stuff. I was far away from that, so I didn't really see it. And like I said, at Google, we in ads there was a shot at MySQL setup, and so you start appreciating what really matters in a production environment. And I also, in particular, predictability and reliability are two things. And also breadth, right? What I saw there was Google was basically using their shot at MySQL setup both as an operational data store, which it's where all the ads, the AdWords metadata went, but also as an analytic data store, because all of the usage, like the click and impression data and the aggregates out of it, were all rolled up and were transferred into the same system. And so there was a data warehouse and there was an ETL pipeline into the data warehouse, but it wasn't very well maintained. And people didn't really like to use it because it was always out of date. People really liked the freshness.
We're looking really at the early days of Google Ads, right?
Oh yeah, yes. We're looking 2003, 2004, right? This is a while back. Now things are different, obviously.
Of course, yeah.
And we'll get to that as well. But so that was kind of I want to say an aha moment, that what really mattered there was the breadth of the workloads, the flexibility that the data management system gives you in terms of the workloads that you can run on it. And the more workloads you can run on it, the better, right? This was basically meant you didn't have to ETL the data, you didn't have to copy the data again, you didn't have to do things with it again in order to have it be useful. So that, in my mind, is one of the key criteria for what makes a database system or the data management system in general useful for a company, for a business.
Right. So now I'd love to sort of fast forward from here, and you're about to create, one of the, in my mind, one of the most revolutionary technologies in the database world that I also had the pleasure of using quite a bit. So talk to me a little bit about this idea behind Apache Impala and what happened in the years to come with it.
Absolutely. I'll actually go back a little bit to the sort of founding idea. So I was then ended up being Google then in ads did a new internal database system called F1. I was the tech lead for the query engine side of that. And I thought that was such an interesting and revolutionary system that I left Google and I wanted to do something like that outside of Google. So I joined Cloudera.
Yeah,
that was kind of the motivation. I joined Cloudera and then managed to get this project off the ground at Cloudera. So this was basically the genesis of Apache Impala. And back then, the world was talking about Hadoop. Hadoop was actually an interesting technology. I think from the technical side, people made a lot out of MapReduce and things like this. But the real driver was really the commoditization of storage and how all of a sudden Hadoop made storage very cheap. And with very cheap storage, people started building data lakes. Yep. And so going back to the idea of flexibility, it seemed completely natural that you would still want to do analysis, and you want to do analysis still with the tools you have, right? There is a very large ecosystem that has grown around SQL, both from the data management side, as well as the user angle, which is BI tools, right? They all rely on SQL. Totally. So it was clear to me that this wasn't going to go away, and that the ability to collect more and more data means that you want to do more and more analysis, not less.
Now, right? What year about are we talking here?
We're now talking 2011.
Okay, and I do want to point out that, 10 years ago, it wasn't very clear to everybody that you want to do this, right? I mean, it was, you're saying it was clear to you, but it wasn't clear to the world necessarily.
It was, I think, if you look back, I think the world started talking a lot about MapReduce and things like this and NoSQL. There was a lot of big push around NoSQL data stores. Mm-hmm. But I think if you look back even farther from a historical perspective, SQL was what made analytics and analytics stores possible. Mm-hmm. But before SQL existed, there was no such thing as BI tools, because writing a moderately complex query that does an aggregate and maybe 3 joins, writing that against a record API, which is basically what a NoSQL system is extremely time consuming, right? So
sure,
if you don't have declarative queries, which today means SQL, you don't really have analytics. So it was clear that, and also going back to Google, right, 80% of the traffic on the data, or 90% of the traffic, was analytic traffic, right? You can write only so much data, but you can read the data and analyze it 10 times over, right? So it was clear that analytic traffic would always dwarf the actual update traffic. Sure. So to me, it was clear that this was still extremely useful technology, parallel database systems, and that there would be absolutely a need to have that in this new Hadoop world. So that was basically the driver behind saying we're going to do Impala.
Okay, so now just to give us a brief overview, what is Impala for anybody who doesn't know the little details about it?
Sure. Impala is a query engine at the most high level, at the highest level. It is an implementation of parallel database technology. So the idea that you have when you have a large collection of data. You have it sitting in a data store. The data store can be accessed. Let's say, back in the days, you had it sitting on hard drives. You can have multiple computers talking to it, and you can process the data in parallel. This is the idea of a scale-out parallel database system. Right. And there have been other implementations of that since. Impala was the first one in the Hadoop space that I would want to say took performance seriously. So we departed from the standard approach and did it in C++, number one. We were the first ones to also do it with runtime code generation right from the outset. And we used LLVM for that purpose. Mm-hmm. And I think all those things contributed to the eventual success of the project. So the focus on performance, which was very clear, given the growing size of data, it was very clear that you needed to have a performance system in order to analyze it. So,
right. And then, so how did it scale, and how did you even get people to start using it outside of where you are? So obviously it served your purposes, but obviously it went into so many developers' tool sets.
We ended up open sourcing it after the initial version. It was open source. I think that's obviously a big driver behind that, right? It could be adopted by non-commercial entities. Yeah. People could fork it or use it for their own production purposes, whatever else. So I think that's an obvious key element for getting adoption outside of.
But even then, when you open source something, it doesn't necessarily, the competition on GitHub now to get the stars, and it's not that easy to get recognition for all the things that you're doing. So was there any strategy behind getting it out there, or did you just release it and say, you know what, it's good, maybe people will start using it and adopting it?
That's basically, there wasn't really a strategy, to be honest, around it. We just put it out there and we worked on making it better, right? Obviously there was the commercial angle, which was Cloudera customers asking for features, improvements, etc. And then those improvements all made it into the public domain code base. And I think eventually it was just recognized that it's a high quality, high performance system. And that's something a lot of people need. So that's why it ended up seeing adoption.
So I'm very heavily invested into working with data right now, both with machine learning at Stanford, but also as just a software engineer. Mm-hmm. And I'd love to get your 2 cents on where are we headed in terms of databases and in terms of how we think of data and store data. Still today we still are kind of feeling limited by the amount of data that we can store, and I have to be conscious of how much am I enlarging and populating my data sets before I start incurring some big charges, even on my GCP or AWS. So do you see this eventually not being an issue, or are we going to see some different ways of storing our data?
I think, just talking about cost, obviously the cloud providers are working on technologies that make it cheaper to store data, primarily by tiering it based on usage patterns, right?
Right.
That said, if you compare storage costs today in the cloud to what you paid 10 years ago when you bought a SAN or something like this, right? When you bought enterprise storage, it's a lot cheaper already.
Of course.
And I think the big thing here that you see today is, again, flexibility, right? The ability to first dump your data without buying and then paying for it incrementally, right? I'm paying for what I'm storing. I'm not paying for a gigantic storage array before I use any of it, right? So I think that is a big driver, and I think this also informs database technology, right? I think you still have data warehouses as a cornerstone of how data is managed and consumed today.
Yep.
But you can also see, what started with Hadoop, the idea of the data lake becoming more and more popular, the idea that you can aggregate and accumulate data before maybe deciding on having a heavily curated schema.
Sure.
Before centralizing everything in a siloed data warehouse.
Right.
Which, in my mind, data warehouse technology is sort of a relic from the 2000s. It's really how it started out, right? Back in the days, you had resource constraints, and you needed to separate your operational data store from your analytic data store, and this is how the data warehouse was born. but there is much less of a need for that, a technical need for that today. And again, going back to the aspect of flexibility, every business needs flexibility. No business is set in stone. And the ability to basically accumulate data, collect data, and then later on decide what am I going to do with it. And then also add resources based on what you want to do with it. I think that is going to become a game changer for database technology. So in that sense, I think seeing cloud databases and cloud analytic services is, becoming so popular is an outgrowth of that.
Right.
The desire for flexibility.
So what gets you excited now? It's 2020. It's been quite a few years since Apache Impala. Where are you now?
I'm still excited about, like I said, continuing on the trajectory of flexibility. So making database technology ever more accessible outside of a traditional data warehouse environment. So I think this is kind of what I'm pushing towards and also what I'm currently working on. So that's one thing. I think more data lake analytics is here to stay, and it's going to become more and more of a force, I think. So that's one direction that I'm also excited about it, because I think it changes the user experience. So far, you still have, I want to say the data warehouse user experience is still shaped by the technology from the 2000s, right? When you had these heavily siloed systems. And I think bit by bit, that becomes less and less technically necessary. And so going to a user experience where you can get analytic functionality regardless of how you collect and store data, right? You don't have to decide in advance, oh, I need to transform everything into a column store and dump all my data into a data warehouse, right? You're kind of getting away from that. Yeah. And saying wherever I have meaningful business data, I should be able to do something with it.
Definitely. So I know, thank you again for your time, and we're just about to reach 20 minutes. And one of the things that I love doing is I love asking the different thought leaders 3 words that best describe them, or how they would like others to describe them. And I find it very interesting to sort of look back now and see how, both the similarities and differences from tech world to the entrepreneurship world to the education world. And if you're comfortable with that, I'd love to also hear what 3 words you think best describe yourself.
What 3 words? Okay. I guess it's probably 3 words that others would use or that I would use. I'll start with myself. I would call myself thoughtful and premeditated.
Nice.
And analytical.
Very, very cool. Marcel, thank you very, very much for taking the time to do this.
All right.
I really appreciate it.
Thank you. And look forward to speaking again.
Definitely. Stay safe and stay healthy.
Bye.
Bye-bye.